Why do you need to confirm 3 times? Why must you act like TCP and send 3 consecutive updates? Wouldn't a single confirmation suffice? Our network layer isn't that complex. Look, 1 confirmation, 1 ACK, isn't that already enough to ensure we can receive? When you send an update and the other side ACKs, isn't that confirmation of the round trip? Doesn't it ensure that the link is working properly? Why then would you need another what? Why send 3 times? What's the purpose of 3 times? This involves what we see in our EIGRP tables, specifically the last 3 entries. Let's first discuss what SRTT is. SRTT, in the EIGRP neighbor table, stands for Smooth Round Trip Time, or Smooth Round Trip Time. It's called the average round trip time. We send 3 consecutive update packets to ensure the reliability of our link and to send routing entry updates. The first purpose is to ensure reliability. The second purpose ensures that the third packet can send routing entry updates. The third purpose is to record an average round trip time. For example, the first time I send an update and you reply with an ACK. For example, the round trip time from sending to receiving might be how many seconds? Maybe 5 milliseconds. The second update sent and received might be 5 milliseconds. The third update and then coming back might be 5 milliseconds. We then record sending 3 consecutive updates. We record such an average round trip time. EIGRP, when establishing neighbor relationships, sends 3 consecutive update packets while ensuring reliability, records the average time of 3 round trips. The purpose is simple, because our EIGRP, as a network layer dynamic routing protocol, cannot ensure the complete reliability of a 3-way handshake like our TCP transport protocol. We don't have things like source and destination ports, so definitely to ensure more security, just like what classmates in ancient times we talked about when you were in the north and I was in the south, we were separated by distances. Then at that time, what did we do? If we really wanted to exchange information, what did we need to do? We needed to find a footman, or what we called a courier service, to help us deliver letters. Right, classmates? So if you, for instance, were separated by distance, we are relatives, she is my wife, and I am here, what do? We communicate through letters. So what do? You have to estimate, you have to calculate how long it takes for letters to go back and forth between us. If you never calculate, say I sent a letter, and 3 days later, I still haven't received a reply. 4 days later, still no reply. You would be anxious. You simply wouldn't know whether the letter was received or not, whether they could see my message. You'd be clueless, because we don't have instant messaging like WeChat today. In ancient times, when we sent a letter, before receiving a reply from the other party, we had no assurance. We didn't know if the other party could see our letter. So what did we do? We continuously sent 3 letters. After 3 letters, we would know the likely average round trip of the reply received, the letter I sent, to the time the other party replied to me. This average time might be, say, 2 weeks. Of course, from the south to the north, it might be 3 months. I remember, I think I read in a novel, it said from the south to the north took about 3 months of travel. It could be a long time. So we estimate the average time of 3 round trips. Now we know I send this letter, and the other party replies to me, it might take about 3 months, approximately 3 months. It's okay for me to receive this letter. So it's simple. It's about recording the average round trip time. Recording the average round trip time, and after we have the average round trip time, what do? The next time I send a letter, send an update packet, I can estimate how long it will take before I can receive a reply from the other party. To estimate this time, of course, there's another function. What function? In EIGRP, in such a table, it's also called RTO. What's RTO? Called retransmission timeout. What is it? Called a retransmission timeout timer. Retransmission timeout timer. So the SRTT time can be calculated from the average of 3 round trip times, giving us a psychological expectation. I send a letter, how long it might take for the other party to reply. So the retransmission timeout timer is like a psychological baseline. The psychological baseline, for example, that previous example, so between 2 places, host A, host B, 1A, 1B, then A, sends a letter to B, B replies to A. We estimate that for A, estimating about 2 weeks' time, I should receive a reply. So 2 weeks is the average time I recorded from 3 exchanges of information, I believe, about how long it takes to receive a reply. So what is RTO? It's my psychological baseline. Like when I send a letter, I think it should take about 2 weeks to receive a reply. But this time, it's been 3 weeks, 4 weeks, and I still haven't received a reply. Wouldn't I be very anxious? Very worried, very anxious, very anxious. I sent a letter. It was supposed to take 2 weeks, and now I still haven't received it. This RTO time might just be what? My psychological baseline, like 5 weeks, my 5-week psychological baseline. Because estimating it takes 2 weeks to receive, but after 3 weeks, I still haven't received it. 4 weeks and still no reply. I sent an update, and it's been 4 weeks and they still haven't replied to me. Wouldn't my mind be in turmoil? Very anxious, so what's my letter's baseline? It's 5 weeks. If I haven't received a reply within 5 weeks, then I'll send another one, an update. After sending it, if 5 weeks pass and I still haven't received a reply, what should I do? Has the other party died? I send another update. And if I still don't receive a reply, then what? I send another update. What is this called? It's called the retransmission timeout. It's our psychological bottom line. If the RTO time is exceeded and still no response to our own ACK message, that is the reply, we become very anxious. We then resend the update, another update packet. If we exceed the RTO time and still do not receive this ACK message, we will resend the update again. And if we send 16 times, let's not talk about 16 times for now, we keep sending this letter and still receive no reply, what happens then? The third thing is called Q count. Q count. Q-U-E-U-E count. C-O-U-N-T is called Q count. This is the last field in our neighbor table, called the Q count. When sending an update packet, this Q will set this value to 1, indicating that I am sending an update packet and waiting for a reply. Once the ACK message is received, the value will be set to 0. So students, when sending an update, it is set to 1. When receiving an ACK, it is set to 0. Therefore, if you notice a problem, if the Q count remains at 1, then there is a problem. It means we still have not received the other party's ACK reply. Students, it means we still do not receive ACK. Then the problem arises, what if I keep sending update packets and still don't receive ACK? I can't just keep sending letters. If I don't receive a package in 5 weeks, I send another one. 5 weeks without receiving a reply, I send another one. There's a number, 16 times. 16 times. 16 times. In our EIGRP, it's called the 16 retransmission mechanism. It's simple. When sending update packets, if it doesn't exceed the RTO time, what do students think? RTO time, if it exceeds the RTO time and you still don't receive an ACK, that is, a reply, I would be very anxious. Then I would resend the update. And if it exceeds the RTO time and still no ACK, then continue to send. After sending 16 times in a row, update packets, if still no response is received from the other party, if after sending 16 times there's still no reply, then it's assumed that the other party has a fault. And then what do? Break off the neighbor relationship. Students, if we send 16 times and still don't receive a reply, I think the other party is gone. I break off the neighbor relationship, or what you might call it, called resetting the neighbor relationship. Either breaking off or resetting, however you understand it. It's important to note that the SRTT, the average round trip time, is calculated from sending 3 updates and 3 ACKs, these 3 averages. The average round trip value is derived from this. Each device might have different values, for example, here it's 5 on this router side. Show IP EIGRP neighbor. We see 2 neighbor relationships. One is neighbor number 0, which is our R1, with an average round trip time of 5. The other is neighbor number 1, R3, with a round trip time of 1. They are different. Students. But what you need to be aware of is the RTO time, this retransmission timer. It is calculated from the SRTT time. It's computed by the device, the RTO, our psychological baseline. RTO time is calculated from SRTT time through a formula. However, students need to be aware that this algorithm is kept secret by Cisco. It has not been published. All right, students, RTO time is derived from the SRTT, but the formula for calculation is not disclosed by Cisco. It's kept confidential, not published to you. After all, our EIGRP, a distance vector routing protocol, is Cisco's proprietary protocol. Only Cisco devices can use it. You can't run EIGRP on Huawei or H3C. Okay, students, EIGRP is our Cisco proprietary protocol. It's confidential. The formula for calculating SRTT, the average psychological expectation, calculated to determine our psychological baseline, has not been disclosed. Okay, students, so we don't know this value, this sequence number. The sequence number is the confirmation word segment given to the packets we send. Students, we just confirmed how this simulator simulates it. No, the image used in our simulator is Cisco's, even though we don't know this algorithm. But it runs inside, how should we say, this version. The version is a Cisco image, Cisco's operating system. Although we can use this technology, but the calculation method of this algorithm has not been disclosed. All right. Okay, students, this is about our Cisco device's neighbor table. The content we need to pay attention to, first of all, our neighbor's queue. We are which neighbor number, who is the neighbor, which interface we built the neighbor with. Then after how many seconds, after so many seconds, if we don't receive the neighbor's hello message, I think our neighbor has a problem, break off the neighbor relationship. Then uptime, I've established a neighbor relationship with my neighbor. For how long? How long have we known each other, SRTT between me and the neighbor? When we exchange messages between us, how long does it usually take on average? Then after how much more time? If I don't receive a reply from the neighbor, I would think there's a fault in our neighbor relationship. Then, queue count. Do we have any update packets that need to be handled right now? No, right? Sometimes that is stable. Then, the sequence number, students. This is what appears in our EIGRP neighbor table. All the content that appears. Do you understand, students? Any questions? You can ask directly about it. Our EIGRP neighbor table. What is the purpose of our update packets? And what is the information exchanged with neighbors used for? What information in the neighbor table is used for what? Any questions, students? Any questions you can ask? Give everyone a moment about EIGRP. Any issues with the process of establishing neighbors? If there are no questions, we will continue. No questions? Really? About the sequence number always changing. Each time we send a hello packet, each packet contains a sequence number. You see, our sequence number is always changing. What is the field of the sequence number at the end? What is the sequence number field at the end? The field at the end, this one. This field indicates the time at the end. It always changes. Haven't we mentioned it? When we establish a neighbor relationship with hello packets, we wait for the other party. That is, after establishing a neighbor relationship, we both continue to send each other hello packets to maintain our such a neighbor relationship. To maintain our neighbor relationship, then use the time at the end to record what? To record the countdown, each hello packet is sent every 5 seconds. If after 15 seconds we do not receive the other party's hello packet, I would think our neighbor has a problem. It's a countdown. It continuously changes. You see, there are still 11 seconds. If in 11 seconds we don't receive the other party's hello packet, we will disconnect again. We will break off again. You see, and then after receiving a hello packet, it will start the countdown again. It will continuously count down for 15 seconds, restart the countdown after receiving a hello packet. So, if after a period of time, we do not receive the other party's hello packet, for example, if I do this on R1, I shut down the 0 interface on R1 on the interface 0. 0, now R2 will not receive R1's hello packets anymore. 8 seconds, 7 seconds, 6 seconds, 5, 4, 3, oh, it's done. 2, oh, wrong, it's done, broken, it's broken. 0, break off the relationship. Break. After the time has passed, if we do not receive the other party's hello packet, we would think the neighbor has a fault. We will automatically break off our EIGRP neighbor relationship, then wait for the next time, for example, we start sending hello packets again. Next time we receive the other party's hello packets, we will start again. Yes, correct. Our update packet sequence, it only lasts once. Just when we have just established a neighbor relationship, we will confirm this reliability confirmation. Only when we have established a neighbor relationship, we will do confirmation. And afterwards, in subsequent hello packets, the service number will not change. It will not change inside the hello packets. It only exists in update packets. Update, for example, if I do this again, I now come with a route entry. I come with one on R1 this side. Now, what is the sequence number, EIGRP neighbor? Now the sequence number is 25. What about R2 this side? R2 this side is 14. Let's do this. If we are R1, add a new route again, interface loopback 3, then 103, 101.1.3.0, 3.1 comma, we declare it into EIGRP, 101.1.3.1. Go, now there's a new route. You see, we sent a new sequence number, a new update packet, announcing a new route entry to our host 24. 0.0.1.0, then R2 received the route. I received the route U, R1, announced I replied to you with an ACK, then your route I received, sequence 15, ACK 15, then the route you sent me, I received it. Now let's look. Show IP EIGRP neighbors. You see, we received the sequence number. ACK reply is 15, received sequence number is 15. What is ROI? RTO, here, read transmission timeout, retransmission timeout timer. After how much time if we do not receive an ACK, we will resend such an update packet again. Any more questions? Students, okay, any more questions? If not, we will continue. This is our EIGRP Hello Packets and our update packets. Its main purpose. 1 is to maintain and establish our neighbor relationship. 1 is to ensure reliability. Then to transmit routes. Then ACK is used for confirmation. Our 3 packets, we have recognized them now. Then the contents of the neighbor table, we have also seen them.